Errors in approximate integration. If the function is decreasing on the interval a comma b, then the left sum is an overestimate and the right sum is an underestimate. If the function is increasing on the interval a comma b, then the left sum is now an underestimate and the right sum is an overestimate. So we see that if the function is decreasing on the interval a comma b, then the right sum Rn is less than or equal to the exact integral, and this exact integral is less than or equal to the left sum Ln. If the function is increasing on the interval a comma b, then the left sum Ln is less than or equal to the exact integral, and this exact integral is less than or equal to the right sum Rn. Observe that these conclusions are based on whether the function is decreasing or increasing on the entire interval a comma b only, disregard of whether the function is concave up or concave down. Decreasing or increasing are the properties of the first derivative of f. Tangential trapezoid. Using the tangent line to the curve at the midpoint, we can draw a trapezoid that has the same area as the rectangle using the midpoint. This trapezoid is called the tangential trapezoid. Moving forward, we use the tangential trapezoid to describe the midpoint rectangle since they have the same area. When we use the trapezoid rule to estimate the area under the curve above the x-axis, we use the two endpoints in each interval, xi minus 1, xi, come up to the graph, and then we connect the two points on the graph to form the trapezoid. This is not the tangential trapezoid, but it is the trapezoid used in estimating the area. If the graph of the function f is concave down in this interval, then the trapezoid used in estimating the area is below the tangential trapezoid, but the tangential trapezoid has the same area at the midpoint. Thus, the trapezoid rule is underestimate and the midpoint rule is an overestimate when f is concave down. Similarly, when the graph of the function f is concave up, then the trapezoid used in estimating the area under the curve above the x-axis is now above the tangential trapezoid, but the tangential trapezoid represents the midpoint rectangle. Thus, in this case, when f is concave up, then the trapezoid rule is an overestimate and the midpoint rule is an underestimate.